Good day. This is Monday, the January 11th, 2021. This is the day we're going to review the important concepts and questions for the Edulastic Unit 4 assessment on Tuesday the 12th. Okay. So with us being back live, I intend to run a live class on this as well. Just going to see how kids in here are doing. There are 10 questions on this. The warm-up and the exit tickets still have to do with division because that's the main topic right now. And problems 1 through 8 will review equation solving. So I'm going to provide video assistance, kind of like an answer key as we go through each question. So I'll be stopping and going. The homework assignment for tonight will be due Thursday the 14th. 4 questions. It's the same 2 questions. I want you to find the quotient, both using long division and synthetic division. So question 1 and question 3 should have the same answers. You're just using 2 different methods. Same thing with questions 2 and 4. On the assessment, if it says to divide, you can use either method. If you have to use a specific method, I'll notify you, okay? Thursday's homework assignment is due tonight at 11:59. And what you see today will be summarized what the Edulastic assessment is on, okay? So as I share the document we'll be working with the rest of the period, I want you to find the quotient using synthetic division. So I'll be back to go over that. Okay, so you're dividing 2x cubed minus 8x squared minus 12x plus 27 by 2x plus 4. I listed all the objectives for the 6 lessons in the unit. That's where the spaces indicate. And if you want to reference notes, I gave you the dates that you would reference one note, going all the way back to right before Thanksgiving. All right, so I'll be with you to go over the warm-up. Okay, let's look at warm-up. Quotient has a remainder of 3. Answer is x squared minus 6x plus 6 with a remainder of 3. So we write that as 3 over 2x plus 4. In the dividend, there are no placeholders. We're just using 2, -8, -12, and 27. The excluded value is 2. And why? Because when 2x plus 4 equals 0, x is -2. So you only have 1 excluded value in this problem. Some of the problems we did on Thursday, the 7th had 2, if it was a quadratic. But most of the time, you're going to have 1. Okay? So in the review questions, just to kind of preview them quickly. I don't have notes, sign problems. Okay, so let's just kind of start here. In the first assigned problem, we have a square root equation. The second one, so the first 5 or 6 of these are just, I think the first 5 are just equation solving. So you get a square root, a 4th root. Question 3 and question 4 are rational equations. And then in question 5, it's a polynomial equation, which you have to set equal to 0. So as I move forward here, I'll go over question 1. Okay. So if we bring you back to question 1, the answer is 7, and it checks out. So when you're looking at a square root or a radical equation, you've got to remember, and the notes will tell you, you've got to isolate the radical. So to do that, I added 4 to both sides of the equation. And then I divided both sides by 3. And we come up with what we have here. The square root of 5x minus 10 equals 5. And to get rid of that radical, you have to square both sides. So by squaring the radical, you're just left with that value inside the radical, the 5x minus 10. That is called, again, the radicand. So 5x minus 10 equals 25. Then add 10 and divide by 5, and x equals 7. Okay. So from there, we can check it on Desmos. All right, and I have this prepared for you, but if you're putting it in, it's 3 times the square root. So the square root is the keypad, radical 5x minus 10. Remember to keep x in a lowercase letter. Minus the 4 outside equals 11. And in order to get this x-intercept, remember we're going to change 11 to minus 11. And we have what we have here. Okay. So as we transition back, the next question is to look at question 2. Solve the equation, and this is a 4th root equation. So I'll be back to go over that. Hey, welcome back. I want to make sure we're sharing this proper screen. So answer to question 2 is 3, the 4th root equation. So let's just go through it slowly. First thing we want to do is still isolate the radical. So we undo the subtraction first, subtracted 4 from both sides. I should have crossed that out, no big deal. And then that value before the radical is 6, so we're going to divide 18 by 6 and get 3. So the 4th root of 25x plus 6 is equal to 3. So to get rid of this index of 4, we raise both sides to the 4th power. So by raising the radical to the 4th power, we just get rid of the radical and we're left with the radicand 25x plus 6, which we see down here. 3 to the 4th power is not 3 times 4, it's 3 times itself 4 times. So it's 81. Once you have this linear equation, x is 3. Okay, so on the graph we check. So I have it prepared for you. So just like last time, I'll show you how you'd put this in. So you can see here that 3 checks out. So we would write it in as 6 times the 4th root. So to get a 4th root, you're going to click function, miscellaneous, and the root with the n in it that allows you to put the index of 4 in it. So you type the index of 4, 25x plus 6 plus 4 equals 22. And we want to set the equation equal to 0. So you could technically, 4 minus 22 is negative 18. So if you change this to, if you took the 4 out, just made it negative 18, it's still going to work the same way. Negative 18. Okay. So 3 is your intercept. Okay. So we want to check for extraneous solutions. Remember, just to review extraneous solutions. So here, we're going to check off question 3. That's question 2, excuse me. And then check off question 1. Okay, so we check that off. And then now we got 2 rational equations. Okay, so we want to, first of all, when you start this, you want to see if this trinomial factors to 2x minus 5 and x plus 4. Okay, so I'll be back to go over that. Okay, regarding question 3, the answer should be negative 12 over 37, which as a decimal is 0.324 repeating, or negative 0.324. So if negative 12 over 37. You notice how the 0.324 just repeats itself. Okay, I'm projecting my graphing calculator to you. Just taught myself how to do that. Whoopee. Should have learned it months ago, but hey, we use decimals, so not a big deal. So what I did up here is not necessary to the problem. I just want you to understand what these, especially for you seniors, because you're going to start to think about taking entrance exams and multiple choice college readiness exams and stuff of that nature. When you see a problem like this on one of those exams, as I told you during lesson 3, the two denominators are usually factors of this trinomial right here. So I'm just showing you here that 2x cubed plus 3x minus 20 factors to x plus 4 and 2x minus 5. So that means that we have to multiply 8x by x plus 4, okay? And we have to multiply 2x by 2x minus 5. And I just cleared the denominators. So everything I have in this row right here in green is from the numerators. What I'm adding in blue is what you should be multiplying each numerator by. And I really should just make it clear that we're multiplying wrong here. We are multiplying, I'm not taking this out, 4x squared plus 5x minus 12. We technically multiply it by 1. Okay. The algebra here is pretty reasonable. 8x squared plus 32x minus 4x squared plus 10x. Just remember to distribute that negative. Equals 4x squared plus 5x minus 12. And then on the right side, on the left side, excuse me, of the equal sign, I combine like terms. 8x squared minus 4x squared gives me the 4x squared you see down here. 32x and 10x gives me the 42x you see here. And what I don't show is what I'm going to talk about right now is that the 4x squares cancel. And we end up with, you see here, 42x equals 5x minus 12. So the constant's already isolated on the left side, on the right side, the negative 12. So we bring over 5x. And to be clear, just don't, this is 0 minus 12, which is negative 12. So x is negative 12 over 37, which I showed you on the TI graphing calculator. So now when we check this on Desmos, I already typed this in, okay, and I didn't change this to a minus, so I'm going to just kind of, this is pretty well prepared. So you do 8x divided by 2x minus 5. Use your right cursor, minus 2x over x plus 4. Use your right cursor. Now this equal sign I'm going to change to a minus eventually. You want the numerator 4x squared plus 5x minus 12 divided by 2x squared plus 3x minus 20. And to get these, let's change this to a minus so we can see that decimal. 12 divided by 37 that we talked about. Negative 0.324. So to reinforce that, negative 12 over 37 in the decimal, the two decimals here match. Okay. So the next question is another rational equation. Okay. This one is probably not as difficult. It's a little bit different but it should work out the same. So I'll be back to go over question 4. Okay, question 4. Answer is 5 over 12. 15 over 36 reduces to 5 over 12, which I didn't round on this. I just said 0.416 repeats, the 6 repeats. So if I round it to the nearest thousandth, it's 0.417. Not a big deal here. So Just kind of review everything step by step. Okay, sorry. So in green here in the first row, we multiply 4x by x plus 5. We get 4x squared plus 20x. We multiply 3 by 3x minus 1. We get 9x minus 3. And we multiply the trinomial on the right. And I did not add that in again. It's not very good. Should be multiplying that by 1. Okay, so it stays the same. And then, okay, as we go from this row with the 4x squared to this row with the 29x, the 4x squareds cancel. 29 comes from 20 plus 9. So on the left side, you got 29x minus 3. On the right side, you got negative 7x plus 12. And it just becomes a 3-step linear equation from there. Okay. Add 7x to both sides. 29 and 7 is 36x. Add 3 to both sides. So 36x equals 15. 15 over 36 becomes 5 over 12. Little trick I want to show you on the graphing calculator right now. If you got 15 over 36 like this, and you want to reduce it, this is not a difficult one to reduce, but you would hit math, fraction, and enter twice, and it reduces it for you. And the reason why I'm showing you that is on a standardized exam, the ratio is going to be reduced to lowest terms. Okay. Then as we check our answer, all right, we type in the equation. I already have it typed in, so I'm going to actually do it with you. Nothing really here to show that's different. So that equal sign I'm going to change to a minus, so it's 4x squared minus 7x plus 12 divided by 3x squared plus 14x minus 5. And change this to a minus so you can actually see 5/12 in there. We want to make sure we're seeing that accurately. So your intercept, that should be your 5/12. So 5 divided by 12, 0.416, repeating technically around 0.417. So we could go back and indicate that we checked it. So this is checked. And for those of you following, we checked number 3 as well. Okay. So in question 5, this is a polynomial equation. You got to set it equal to 0 and solve for x. So I'll be back to go over that. Okay, welcome back. Question 5 has 3 solutions. So these polynomial equations, we're going to have one solution by factoring out the greatest common factor, which is always going to be 0. And then the 2 others, which are 14 over 3. This is a 3 and negative 3, so I'll fix that. Okay. So before I check it on the graph, we set the equation equal to 0. That's what we show here in the first row. In the second row, we factor out the greatest common factor, which is x to the 4th power. We divide all 3 terms by x to the 4th power. We end up with x to the 4th power times 3x squared minus 5x minus 42. And I didn't write in what I did with the factoring because I want to kind of go through it. This is a challenging one. So when you factor the quadratic, it's 3 times negative 42, which is negative 126. So remember, guys, it's a times c. It adds to b, which in this case is negative 5. And this is not an easy one to use, but we come up with negative 14, and positive 9. Okay. Negative 14 times 9 is negative 126. Negative 14 plus 9 is negative 5. And by using the divide and slide method, we divide both by 3. And then we apply the zero product property and solve. So x is equal, if x is the fourth power equals 0, x is equal to 0. If x minus 14 over 3 equals 0, this is a 14. X is equal to 14 over 3. Let's clean that up. That's over 3. And x is equal to negative 3. Okay. So when you check the answers on Desmos, I already have it prepared for you. Just type everything in. 3x to the 6th power minus 5x to the 5th power minus 42x to the 4th power. Okay, so negative 3 is easy. And then 14 over 3 is 4.67. So let's, 14 over 3 is 4.67. So you got your 3 intercepts. Okay. Okay, and there's 3 more division problems to go through. I'm actually going to use the graph with a little bit with this, just to show you what some of this means. Okay. So it says you can use long or synthetic division. Just kind of want to plan ahead here. You could go through both methods, but I'm going to make this a little quick and just use synthetic. I'll be back to go over it. Okay, so I'm not going to bore people because we've done this. What I'm going to show here is using both methods, you get a quotient of 3x squared plus 12x. I'm going to change the 12 in here. I am nitpicky. Hold on here. One of these people, I could drive you nuts. I apologize. You're just going to learn to laugh this stuff off. So plus 12x plus 44. The remainder is 183. So I'm actually going to show you how to check your remainder today. Something we skipped over this year, the curriculum, called the remainder theorem. So I show you both methods. So how would you check this on Desmos? All right, let me show you what you do. I didn't show this in the regular lessons, but you would take the dividend, all right? I'm going to go to put the dividend in, 3x cubed. That's 4x, and you don't need parentheses. What you do is this, you create a table. In your table, the excluded value was 4. Type the 4 in. So when x is equal to 4, f of 4 is 183. So that 183, that is actually your remainder, okay? So if we plug 4 in and get 183, we know that our remainder actually gives you the output on the actual graph of the function. Okay, so if a quotient has a remainder of 0, when you plug in the excluded value, it should give you 0. That's a way to check your remainder. Okay, so we're going to assume that these are all set. I didn't check off the ones before for those of you following. Those all checked out for the graph. All right, so for 7, I'll come back to go over this, but for 7, pretty much the same thing here, but just remember if when you use synthetic division, you have to divide all the coefficients by 2. So I will be back to go over that. Okay, on 7, again, I feel on 7, the synthetic division is the easier of the two methods. So the answer is 2x squared minus 2x plus 1, and the remainder is 3. One thing I did not mention on question 6 is that you needed a placeholder in the quadratic term if you just go back. I failed to mention that. So I show it in the synthetic division, and then I showed it in the long division down here. No placeholder necessary in question 7. Excuse me. Okay. So just the only thing I would say here is that your remainder is 3. If you can see here in purple, you have to go back and divide the quadratic, linear, and constant coefficients by 2 because 2 is the leading coefficient in your divisor. Okay. And the work for the long division shown below. Okay. So to check that the remainder is 3, we're going to do the same thing we did. -3 is your excluded value. So I'm going to go to Desmos. Okay, I'm going to type the function in. I copied and pasted. I want to make this. Then when I did my table, my excluded value is -3, which it only gives you -2. Defaults to -2 to +2. So at -3, here you go. It's exactly what the remainder means. So when you're dividing this polynomial by 2x plus 6, you're at +3. You're like 3 units above the x-axis. Okay. So that being said, your remainder checks out. So we're going to assume the rest of it's good. All right. So this is all good. And then to come back for the final video. Sorry to hold you up. In question 8, says you must show long division. I will never, ever write a question saying you must show long division on multiple choice. 3, 10. Yes, you must show long division. Well, technically you don't. Long division is the preferred method. So I'm actually going to extend that video and show you how to use synthetic division. Okay. The key is on this one that the roots, the solutions to the quadratic on the bottom are imaginary. So I'll be back to go over that. Okay, so the quotient here should be x minus 7. A little bit different, but something definitely attainable. So x minus 7. So basically here, you're dividing a cubic by a quadratic. So you got 3 terms in your divisor. So 2x cubed divided by 2x squared is 1x. And then, of course, I distribute here in purple. We've been through this. And then we end up with 2 terms, -14x squared, -54 plus 5 is -49. Then we bring down to 35. -14x squared divided by 2x squared is this -7. So all 3 terms cancel out. So you have no remainder. Okay, but your excluded values. Now, if I took you through doing this synthetically, this is how you would do it, all right? If you want to use synthetic division here, here's the problem. if I wanted to find the x-intercepts on the divisor, all right, 2x squared plus 7x plus 5. Watch what happens. It actually works out. All right, this is actually going to work out easier. So your two excluded values will actually do it. It's negative 2.5 and negative 1. All right, so let's just make note of that. So it's actually going to be a little bit shorter than I thought. So your excluded values, negative 2.5. I wanted to show you using imaginary, so you can get that later. And what else did the graph say? Negative 1. So this is where you go through it twice. So if we start with negative 1, coefficients for the dividend are 2, negative 7, negative 54, 35. So positive and negative 35. Positive 35. All right. So I didn't prepare this. I want to like do the same thing. 2, negative 2, negative 9, 9. 9 minus 54 is negative 55. And then 55, and that's 90. And we're going to do 2.5. Or negative 2.5. Be done with the decimal, believe it or not. So 2 times negative 2.5 is negative 5. Added to negative 9 is negative 14. Negative 14 times negative 2.5. I'm fearful I copied it. It's 35. Minus 55 is negative 20. This isn't going to work. What did I think I copied these down. Two x squared. 2x squared plus 7x minus 5. Oh, let's go back to the graph. There was a mistake here. So I told us your two roots, right, are irrational. So let me show you what you do here. Everything I wrote down is nonsense, so let's erase that. You got to find the excluded values through the quadratic formula. Just taking up a lot of tape here, but it's extra stuff. So for those of you who are really interested, you're going to watch it. All right, so 2x squared plus 7x minus 5. So I find the excluded values for the quadratic formula. So I do x is equal to negative 7 plus or minus 7 squared, 4 times 2 times negative 5 over 2 times 2. Now watch how this works. It's beautiful how it works. This is 4. This is very, very hard. So, you could do this. So your radical is 49 plus 40. So it's radical 89. That's why you see those. God, notes here so long. Right. Now you could actually do this. It's very, very, very complicated. What you would do, I'm not even going to do it. Trust me, I can do it. So if you want me to go over it, just let me know. You put your excluded values in like this. You have to use the exact value. That's the problem. So technically it can be done. So I put this out in the notes. I'm not going to waste any more time. That would just drive you insane. But what you do, I'll just write the coefficients. 2, -7, -54, and 35. What you would do, you would take the 2 and multiply it by this number. And you take the actual product and add it to -7. If you did that using the -7 plus radical 89 over 4, and the -7 minus radical 89 over 4, you would get a remainder of 0. Okay. So this problem, just to kind of, I really lost. You really should be doing this just using long division. Okay. So I'll be pretty specific on this. I'm going to put this out early and go over it Monday. If you have any questions, feel free to reach out to me. Okay, peace out.